In this video, we will determine the domain, location of holes, and equations of vertical and horizontal asymptotes of the given rational function. The first step is to factor the numerator and denominator, which has already been done for us. The next step is to find the domain. We exclude the zeros of the denominator from the domain because division by zero is undefined. It's important to find the domain before we try to simplify the function. So looking at just the denominator, x plus 6 is equal to 0 when x equals negative 6. X minus 4 is equal to 0 when x equals 4. X minus 1 is equal to 0 when x equals 1. These are the inputs or x values that would give us division by 0, and therefore they must be excluded from the domain. X can't equal negative 6, x can't equal 4, and x can't equal 1. Or we can say the domain is all real numbers except these three values. To express the domain using interval notation, because negative 6 is the smallest value, starting on the left, we'd have the open interval from negative infinity to negative 6 union the open interval from negative 6 to 1 union the open interval from 1 to 4 union the open interval from 4 to infinity. Next, we'll determine any holes. The zeros of any common factors between the numerator and denominator result in holes. But notice for this rational function, there are no common factors between the numerator and denominator, and therefore there are no holes. So for the holes, we'll write none in our notes. And now let's find the vertical and horizontal asymptotes. The zeros of only the denominator result in the vertical asymptotes. And again, nothing simplified here, so the zeros of the denominator are the same values that we excluded from the domain. So again, x plus 6 is equal to 0 when x equals negative 6. X minus 4 is equal to 0 when x equals 4. And x minus 1 is equal to 0 when x equals 1. But the vertical asymptotes are lines, and therefore we should give the vertical asymptotes as equations, which again are x equals negative 6, x equals 1, and x equals 4. And then finally, for the last part, we're asked to find the equation of the horizontal asymptote. To determine the equation of the horizontal asymptote, we need to determine what function value we are approaching as x approaches infinity or negative infinity. So let's see if we can determine the end behavior. As x approaches infinity, let's see if we can determine what function value we approach. And we should be able to determine this end behavior in the equation of the horizontal asymptote by analyzing the degree of the numerator and denominator. Notice how if we were to multiply out the numerator, we'd have an x squared term, and therefore the numerator is degree 2. If we multiplied out the denominator, we'd have an x cubed term, and therefore the denominator is degree 3. So because the degree of the denominator is more than the degree of the numerator, as x approaches infinity, the denominator increases faster, and therefore the function values get smaller and smaller and approach 0. And since as x approaches infinity, f of x approaches 0, y equals 0 is the equation of the horizontal asymptote. Before we verify all of this graphically, in the homework, you are only asked to enter the x values of the locations of the holes and vertical asymptotes. So because there are no holes, you enter D and E. And for the location of the vertical asymptotes, they would be at x equals negative 6, comma, x equals 1, comma, x equals 4. And now let's look at the graph of the function. Notice how we do have breaks at x equals negative 6 here, x equals 1 here, and x equals 4 here, verifying the domain. We also don't have any holes. And again, we do have vertical asymptotes at x equals negative 6, x equals 1, and x equals 4. And the horizontal asymptote is y equals 0. I hope you found this helpful.